Gaikwad sir has a more than 35 years of industrial experience. He has worked at a sites with eminent engineers like Mr. Hans Kelm from Germany, and he was instrumental in the Zuari Mandovi bridge for launching, fabrication, and so many other activities. Apart from his handsome site exposure as a execution works, he also has a good a huge experience, not good, a huge experience in quality control, like concrete mix designing, concrete testing, then temperature controls, and so many things which we used to regularly face in AFCONs. And then post to this execution and QAQC, he has been later on, he took his responsibility of knowledge management on his shoulders, and he has given India's one of the best knowledge management system for a construction company. So that was a really a great achievement in industrial in industry itself. And for past about 5 years, he has been associated with Larsen and Toubro in this high-speed rail project. And there also he has done so many. He has acquired so many benchmark, achievements, and he has been a regular trainer for L&T's knowledge initiatives. So now, without wasting any further time, I welcome Shri Deepak Gaikwad sir on behalf of ISSE Mumbai, and request him to start his presentation. So one request to students: please keep yourself on mute mode. Whatever questions you have, you either can put it in the chat box, or you can keep it in the WhatsApp chat box which we have for the student webinar. So, sir, over to you.
Yeah, thank you, Mr. Vivek Abhyankar, and for nice introduction. And I welcome all the students for this particular webinar on a case study, specifically, which was my one major projects that I handle as a quality head in way back in 1992 to 1995 at Goa for constructing railway bridges for the rivers Zuari and the Mandovi. It was actually a very good opportunity given to me to lead the quality over there, and with the eminent leaders like in the field of Mr. E. Sridharan from the Konkan Railway. He was a dynamic personality. Then we had the Mr. S.D. Lime, who was actually a designer for this Konkan Railway entire stretch. I will just brief you how this project actually was, and what was the scope basically that the work involved. And there were many personalities where they're involved from AFCONs, like Hens Kelm, who was a director in AFCONs and very instrumental bringing in all the technologies like pre-stressing, erection of these girders with the hydraulic technology, and the basically the pneumatic caissons. So today we are not going to cover in this pneumatic caissons. Later on, I think in some of the webinar we'll cover this. Because of the time, I think I may not be able to cover all those things. So this is what, and from then actually, as Mr. Vivek explained, I did many things in between, and now I am at the bullet train project. We almost completed that package, and will be over by 6 7 months. So I'm going to start now. So this is what actually you can see our bridge at Zuari, okay, at the left hand side in 1992. This was my starting basically, and now where I am at first bullet train project of the India. I'm heading this quality, and really last 5 years I got very huge amount of experience on field. So this again I will be sharing one of the webinar with you people as a student. I will share all my knowledge in part by part, what we exactly have done over here, okay, in the coming days. So let us start and see what we did actually in 1992, which really still stands high challenging projects, and the technology that involved was really huge. So we are going to discuss today, see how we did basically pre-stress. precast full span box girder, 53.5-meter long, how the casting was done, and what we really did there, how we ensure the quality. That I will brief you in this particular presentation, and then how this was erected in the marine. What we really did there, okay, how the technology was used, how the water tides were used, and this erection work. Uh, uh, Actually we did. Then very important, now we did the steel girder assembly and erection, okay, with the Sayadri hydraulic barge. So that barge also I will show you how it functions and how we did it. And then a small portion will cover about the pre-tension T girders, casting and launching. Here, very specifically, we use this steam curing for this 22.8-meter long span. Okay, so then at the end we'll have some question and answers. So let us begin now. Try to understand when we are there and this complete Konkan railway project, how it looked like. Okay, now you can see the route length. It was 740 kilometer. It has 58 stations, 179 major bridges. That linear waterway, if you cover in this, is a 21.5 kilometer. Minor bridges 1670 number. Grade separators 288 numbers. Tunnels 92 numbers. Aggregate length 83.6 kilometer. Earthwork 90 million cubic meter. And HT substations 39 numbers for the tunneling works. The huge work was involved, and really it was the Konkan Railway who did it really very well with the quality and the way they executed this project. Really, it was appreciable. Now I'm talking about the construction of the Zuari Mandvi railway bridges. Okay, here we are going to basically discuss two important things. Now let us see how it was situated. Now, if you see the Mandvi 1 bridge and Mandvi 2 bridge, this was near to Old Goa. You can see here basically the first part, Mandvi 1 bridge, it was in the Old Goa, that Mandvi River channel, it was crossing that railway line. So we built a Mandvi one bridge over there. The second bridge was there here near basically a Diwad Island. In between that island is there. So connecting these two islands and moving towards the Dicholim, this second bridge was there on the same Mandvi River, the channel. So it called as a Mandvi River, Mandvi 2 River Bridge. Now this is the one part, and the other part was at the near to the Vasco airport. Okay, when you reach Vasco from Panji, so in between, when you take right turn, before that one Zuari bridge comes. A road bridge was there earlier. Okay, and then we built here the Zuari River Bridge. Basically, this was a very challenging and tough because a lot of current was there in this river and tidal variations as well. So you can see here basically the scope of the work Mandvi 1, Mandvi 2, and Mandvi 3 had. Here we had a number of RCC piles. Okay. Then the pneumatic caissons were actually, if you see here, they were very challenging. And typically, this complete technology was brought from the Germany, from our one of the director in the FCONS. And it worked very well and did a good job in this. Now, other thing that PSC T girders 22.8 numbers, we had almost 66, 24, 90 numbers across all three bridges. Then the important and challenging task was casting of the 53.5-meter box girders, almost 800 metric ton weight, and then steel girder. Basically, there were three number of steel girders of each. This were used for the navigational span in the river. Now let us try to understand how we did the 53.5-meter pre-stressed concrete girders, okay, post-tension, and how we did the erection. Now, if you see, look at the features. The length was 53.5 meter, top width 5.7 meter, bottom width 2.8 meter, height 3.7, and weight approximate 800 metric ton. Okay. Now, if you see, look at this particular drawing. Okay, this is how it looked like basically. Almost 23 stands, 15. 12T15 system was used here for the pre-stressing, and this actually was a challenge at that point of time, casting of this pre-stress precast girders, because just prior to some few years earlier, one of the bridge at Panjim in the Mandovi River, it got collapsed, and the reason was understood that the corrosion of the pre-stressing strand. So, lot of emphasis was given here to control the quality of the concrete as well as during the pre-stressing and grouting. Lot of precautions were taken, and really we did work very well. If you can see this is a photograph how it looks like. We had basically a two bed here. One is a casting bed on which we will basically uh, clean the bed, and with the help of jig we will put the reinforcement for the bottom and the web portion. And we had the another casting bed where we will keep our shutters for cleaning, refurbishment, and and then as we complete this bottom reinforcement and web, and we place all our sheathing duct, GI sheathing duct, then this inners and outer will come in on the casting bed. It will get aligned properly, and then the portion for the top reinforcement will be done. It will be checked properly to the line and level, and then the casting will start. So now you can see this is how it looks like. You can see the one portion here. Just a minute, I will take pointer. Is right. You can see here now. This is what is a casting bed here. Okay. The other second bed is for the shutters basically. It's called a bed for the shutter. And now here all the castings will take place. Okay. Now here we have our batching plant on land, and here at the jetty we have another batching plant. Okay. So this batching plant here is in a floating condition, which will actually do all the concreting inside the marine. But when we have to concrete this particular full span girder, we'll bring this also, and we'll use both the batching plant CP30, and we'll do this casting. So the basic challenge here, if you can see, was to control the ensure that it is there is no cold joint formation in this particular casting, because such a 3.7-meter height and almost 3 cube of concrete doing at that time in 1992 was a very challenging, because at that time we did not have super plasticizers which we have right now, like PC based third generation admixture. That time we used to have only a naphthalene sulfonated based admixtures, which used to give a water reduction up to 15 to 20% somewhere. And so we need to maintain a water cement ratio zero point 0.4. We could not reduce less than that, because if we want to do, then we have to increase the cement content. If you see, for this particular concrete with this kind of admixture available at that particular period, we had to use cement content up to, yeah, somebody is talking. Uh, we had to use cement content up to 480 to 490 kg per m cube, and the water cement ratio we could restrict up to zero point 0.4 and less. We use at that point of time in between 0.38 and zero point 0.4, less than zero point 0.4, but not less than 0.35. Okay, so but still we had a very strict control on the raw materials like sand, aggregates, and we used to do regular gradations, combined gradations. We used to check in within the envelope it is there or not, and then used to conduct lot of trials, and we used to check the initial setting time of concrete. This initial setting time is very important to ensure that whatever concrete we are laying during the casting, we put subsequent layer before the initial setting time of the layer beneath that. Okay, so that is very important, because if the layer beneath that it gets set initially set, okay, then there definitely will be a cold joint, and it is going to basically affect the life of the structure, because there will be a easy movement of the moisture inside the structure. Corrosion will get, reinforcement will get corroded, and definitely then the structure will not last as per the design life. So the controlling of this concrete for the initial setting time and doing placing properly, planning pour properly, and observing at site during concreting was very, very important. And really, we did very well that time. Lot of supervision was there, and we used to see basically how we used to check the initial setting time was we used to take the concrete in a 15-liter bucket, fresh concrete, then put the 25 needle vibrator in that and just take it out gently. See if hole is forming or not. Okay, the moment we used to observe and we used to notice that the hole started forming, that gives a signal that concrete is just started getting initially set. So within that time, we have to place the subsequent layer. So that we used to observe very, very religiously, and uh, very well we did there, and we cast all our FSLM without any cold joints successfully. So that was a key challenge over there. So we need to take lot of precautions like water admixtures batches we are getting there. It will be checked for the initial setting time, slum retention, and the cohesiveness, bleeding, etc. All that. Then only we will qualify that batch of admixture for this casting of this precasting girders, and we used to do it successfully. Still, we had our own challenges over there. Okay, but we could overcome properly. Now, if you can see here, the casting, okay, in the shade was there to ensure that there is no direct sunlight, no wind, etc. So, a lot of precautions we had taken at that time. And then this shade will also move here to the after casting and doing all the work over here after curing. This particular girder, then after doing stressing and all, okay, it will be pulled on the loading jetty. So this jetty, what you can see, is a loading jetty. Okay, so from this only each girder will get lifted with the Sayadri barge. The Sayadri barge will come here inside. Okay, it will come in this direction, it will enter inside. That exact portion will be match here, and with the hand winch it will be fixed. So during low tide it comes inside. Then rubber plates, neoprene pads were kept on the Sayadri barge. Okay, it will just get connected with the bottom of this particular full span box girder at the given points. And then when tide rises, this particular FS full span box girder precast will get lifted. Okay, and then that barge will be taken out, and the whole further process will take place. Now here you can see this is the setup for the casting of the full span box girder. Yeah. So what you we have discussed here, this is the process what we basically followed. Okay. This is the shutter preparation. Okay, cleaning and all that sort of thing. Getting this will on the shutter preparation bed. This will happen. The casting will happen on the bed too, casting bed. Then the bottom slab in reinforcement and web reinforcement will be tied up. This is what I already explained you. Okay. Then the shutter shifting, top reinforcement, putting sheathing and all, and doing the concreting. Okay. So this what two CPT plant, CP30 plants were there. Or died. We used to take. It used to take almost 20 hours to do the 300 cube concrete. Now I will just brief you. Now just I will just compare now at that point of time. Still at that time when we were using CP30, it was really new to all the people, because at that time we were not having automatic batching plants in India quite widely used. Only few locations you will see. So here one of the project where we use this CP30 lever and the stator batching plant, the people were actually amazed to see this. This were the actually semi-automatic batching plant, but having very good capacity, good mixing and all, good control, good cohesive concrete we used to get. Okay, still it used to take 20 hours. But now at Bullet Train project, we are casting 40-meter long full span box girder precast post tension. Okay, these girders now we do 400 m cube in 6 hours. So this is what drastic change you can see now has happened. Now the speed and pace of the construction has really tremendous. Now this particular here at this particular project, still I can say with the available resources we did really well, and really we have to appreciate Konkan Railway for taking all the measures, and AFCONs really anticipating and supporting Konkan Railway, and doing all the work with the quality. It was really good teamwork. Now we are going to talk about the Sahyadri Bash. Now casting we have done. So now we have to erect this particular full span box girder in the marine conditions. Okay, because river is there. So river there, you cannot do anything. You have to have floating crafts only to do this erection work. So by hydraulically we used to do. But this particular barge was designed by our director, Mr. Kelm. Okay, he was good at all the design and all. So he brought this technology. He designed. Okay, and this you can see the Sayadri barge has two barges. Okay, 14-meter by 40-meter each, connected by the steel lattice, and the total dimension of the complete barge is 40-meter by 40-meter. So on this barge we had two towers. These two towers were high at 18-meter height. Okay, and each tower was equipped with the four hydraulic jacks, 125 metric ton capacity each, for the lifting purpose. And the lifting speed was 300 millimeter per minute, stroke by stroke. Okay, and for positioning purpose, we use the six hand winches, 10-ton capacity each, to ensure that we perfectly position this Sayadri barge at the erection location. And for this double chain connected anchor arm bracket was used on this barge for the pulling purpose. The anchor arm with 4 inches plates we had there. That. So this is a brief about the barge basically. We'll show you the photograph also. Now we had seen in the one of the photograph, okay, the loading and erection, that loading jetty I have shown you. So on that the girders were stacked post curing, and when Sayadri enters during low tide, it lifts that girder. Okay, it we use the reinforced neoprene bearings. 20 MS plates were used in that for the manufacture of this kind of bearings. The dimension was 660, 390, and 52. Now, very important here was that for the design perspective, now since we have to lift this, and this is a pre-stressed structure, okay, so there are chances that tensile stress will be induced during the lifting. So now what we did the temporary stressing, okay, as per the design only, to perform the lifting. So prior to lifting, we did this just temporary stressing. I will show you the diagram. At the end of the anchorage, two steel frames were put, and it was traced on the anchor portion. Okay, to neutralize the tensile stresses in the slab. Now, after doing this stressing, the girders were moved to the location with the Sayadri barge, and then hydraulically it was placed on the span. Now you can see here, this is stacking jetty. You can see here, and all the after casting this each girder one by one, it used to shift towards the loading point. Now, the temporary stressing which I was telling you, now this is what you can see is a temporary stressing arrangement. This is a steel frame attached at the end, okay, and these are the HTS strands, okay. Those are actually connected here, and the stressing was done. And after doing this only, this girder got Sayadri will lift this particular girder. It will take it to the span, and it will do the erection. See here the Sayadri Bash will come inside, and this is what you can see is the Sayadri Bash. This is only specifically used for the 53.5 meter pre-stressed concrete girders. Now you can see there are two barges, as I told. In between, it is connected with the lattice, and now these are the two arms having the four jacks, hydraulic jack each. There's a chain arrangement, double chain arrangement for lifting. This is a temporary stressing. What you can see now, this has brought this FSLM full span box girder in this on in between the span, lifted, and then it has actually lowering on the bearing pedestal, on the elastomeric bearing. Okay, this is how the whole operation used to happen, and the lot of careful calculations we need to do for the tide and the current and the wind velocity, etc. By looking all these aspects, we used to plan our erection works for each of the span. This particular activity was done to because the casting was done at Zuari Bridge only, the casting yard. But a few of the full span girders were actually need to be transported to Mandovi, which was there at Old Goa. So this the way how it got transported through a sea channel. Okay, it used to come from that Miramar beach, from that Zuari, got turned from Panjim, go towards Old Goa, and then there this particular if box girder will be erected on the ready spot. But this complete this activity was also a very critical activity, transporting this 53.5-meter PSC box girder in a floating barge. So a lot of precautions used to take. Now this was all about the casting of the full span box girder, 53.5 meter, okay, and erection. Now the second part is there we had 22.8 meters T girders. Now in these T girders there were huge numbers were there in numbers. So we need to ensure that production cycle. So to enhance the production cycle, we had to do the steam curing. Now, for the steam curing, if you can see, the cycle was like this. It was a 48 hours production cycle, basically, totally cycle time. The casting of the each of the tea girders, 22.8-meter long. So here we used to do the steam curing. After concreting for 3 hours, we'll keep it for initial pre-setting time, and then the temperature will be taken up at a rate of 10 degrees centigrade per hour, not minute. It is wrong. It is a minute, 10 degrees centigrade per hour. This is a temperature rise. And then the holding time at a maximum peak of 60-65 degree, we'll keep it for 9 hours. And then the cooling will be done same gradually at the same rate, 10 degrees centigrade per hour. It will take somewhere around 4 hours. Very gradually, we'll do this, lower down the temperature, and then the cube will be tested, and we get M35 strength. Normally we used to get in within that stipulated time. Then the distressing will be done. The strands will be cut because it's a pre-tension, and girder will be lifted and shifted to the stacking yard where the curing and everything will be done. Now here very typical trolley we use for launching of this T girders. It is called CSAT trolley. This is again the technology at that time they use in Germany. Then it was brought by our design uh, director, and all the deck slab elements, everything they were done at this site location. This you can see here, the T girder. Here, this is basically a concrete trough. Okay, this push, this what you can see. So in between shutter is there, collapsible shutter, and then the reinforcement will be basically fabricated outside with the jig. Then it will brought with the gantry, will be placed inside. Shutter will be closed. We'll do the concreting, and then the on this trough, after pre-stating time, we'll put the hood over this particular trough, and it will be completely covered. And then the steams will be allowed to pass through all this chamber, and will maintain the temperature. And with the cycle, this particular steam curing design cycle will be followed to achieve this training. So 3 hours, 9 hours, and the 4 hours. This is basically a shuttering arrangement. It used at other projects of the AFCONS also. This is how the complete layout was there for this tea girder casting. You can see a stack at number one, two, three. There's a two trough we use basically for the casting. Oh, trough one, trough two at the Zuari bridge. This is how the seaside trolley will work. It is basically as a rail and all the type of things. So two the trolleys were there. These trolleys will come towards the casting yard, casting bed, and there this basic sorry stacking bed, and in stacking bed with the help of the gantry, this particular tea girders will be placed at one particular location. Then it will be pulled with the sliding shoes towards the seaside gantry. It will be lifted, and then this gantry will travel to the required span. And then this particular tea girder will be placed over at one location, and with the help of the arrangements and sliding, this will be moved to the extreme end. All there were three tea girders, then the diaphragm and everything will be done. This is how you can see the real photograph. This is a seaside trolley you can see. Okay. And this is the arrangement for traveling of the seaside track here. Right? This is how it then we'll all do the curb and everything will be done on this place. So now this was a very very challenging work basically given this fabrication and assembly was not done by the Afghans. Afghans only did the erection part of this with the Sayadri. So how we did it, that we'll see. It was very, very challenging. And that time, MD Mr. Sridharan, he himself witnessed one of the launching of the steel girder. He was very happy the way the work carried out by the Afghans, and he had given then the to entire team of the project. He gave the appreciation later. So this what you can see, okay, is a steel girder basically. Okay, the steel girder, if you can see, it is basically assembled. Okay, because the components will it was done. The work was done by the Maharashtra fabricators. So the components will was brought to the site. Then it got assembled by doing the riveting work. Okay, that time we use the Konkan Railway use the riveting. So why with the riveting, this complete assembly was done, and then you can see this is the arrangement for the sliding of the complete steel girder. Okay, so this sliding arrangements for pulling full it was done, and this complete steel girder at this location it was pulled on the inside the river. Okay, and then was placed on the dolphin, cast inside river, and then it was being picked up by the Sayadri barge and launched at the location. So we'll see this how what you can see is being basically getting assembled at shore on shore. Okay, this is a 125-meter long steel girder at height at mid location. The height is 16 meter. Now this is the Sayadri barge. Basically, if you see earlier we had a two towers. Then later on, because this weight is somewhere around 1,000 plus, so we had to modify the Sayadri barge, erected two more towers with the required capacity of jacks and all. Okay, and this was used. Now this particular you can see is being used for the 124-meter steel truss girder. Now this barge you can see now here it is in the location. Okay, position properly. Now this steel
क्या
girder is reaching, being pulled towards the Sayadri barge. Okay, it has been assembled
नहीं
here on
ये चालू
shore.
नहीं हो रहा था कितनी देर
Now
से
with the sliding shoes and all the
मतलब वो
sliding arrangement, it is being
ये
pulled
ऑनलाइन
towards the
एमएस टीम
Sayadri barge. Now the Sayadri
तो
barge
फिर
it
बाद
is
में जलाया मैंने
perfectly positioned now. It is on the barge now. Now we are waiting for the tide to come, and when the high tide comes, it will lift up this particular whole assembly of 125-meter, having somewhere weight around 1,000 metric ton. Now you can see here now it is in a floating condition. So now this is being towed towards the uh, navigational span. Now here what you can see, these are the hand winches here on the pontoon. These are the boyas. On this, it is basically towed at one particular location. Now, this is being transported to the required location, okay, with the motor truck. It has reached to the location, being perfectly positioned. And now here you can see just entering inside. Okay. Now truss is launched at the location and it is in the exact position. Now this is how basically complete uh, picture of the erected span of the two steel girders. This is the two navigational span of the Zuari bridge. Okay. So now the story behind is that lot of effort were there involved in this. Lot of technical people learnt lot here in this particular project for this pre-stressing, pre-tension, post-tension, marine piles, pneumatic caissons. We had lot of ground improvement work using sand drain, band drain, uh, and we use rotary piles there on the land at that time. So this was everything was a new like thing for the people to learn a lot and really including Konkan Railway, AFCONs, and many students of the Goa college and other college also they visited this project and learned a lot. Like a college from the Farmagudi, they also visited quite frequently and a lot of visits used to happen at this project from the Konkan Railway itself to see the project to learn from this. So this is what the appreciation letter I got basically doing my part of work, and it was really appreciated by the complete member of the Konkan Railway because for them our complete quality setup was like a centralized quality control setup for the Konkan Railway at that Goa and around region right up to Ratnagiri. So the people from that all project they used to come to us to do their mix design, testing, guidance, training, etc. So this is what I got from this particular project as a recognition. Now, when we completed basically 25 years from this project, so all the people from this project, right from Mr. S.D. Lime, Chief Engineer Design, all the chief engineers like Gupta sir, Dabadkar sir, then we have many Konkan Railway engineers now, though some of them are at very high positions, they also had come. And our seniors like Kashalkar sir, Mr. Giridhar, Dr. Nayak, NV Nayak, all these people they have come here and we had after completing this project 25 years we all got together and we have celebrated very enthusiastically at Navi Mumbai. Almost around 50 60 people were there for this celebration as a reunion meeting and celebrating 25 years completion of Zuari and Mandvi railway bridges. You can see here Mr. Dr. N.V. Nayak, Mr. S.T. Limeyev is also there, Mr. Kashalkar sir, then Mr. N. Jangle, Mr. Giridhar, he is now Deputy MD in the AFCONS, is M.B. Joshi, Mr. S.B. Joshi, these are all on people on top. Mr. G.H. Bird, Mr. Indudara Sastry is executive director in the high-speed rail now. So all these people are there. They were there involved for this execution of the projects, and they were very happy to gain the knowledge and see that the project still goes on quite very well and standing really tall. So this is what is there from my side now. You may ask questions. I will just play a video, I think, for you to see this project, how it looks like really right now. This is a video, not now, but 2000. Is that? Yeah. No.
बोल भाई. हाँ.
Okay, that's all from my side. It's open for you to ask some questions.
भक्ति मेरे को भी जाने की है.
Good session, sir.
ऐसा क्या वही पैरापेट वॉल का ही
Uh, yeah.
कंफर्म है तेरा.
So, students, any question? Please feel free to ask. Because Deepak Gaikwad sir has a uh,
Your voice is
huge,
very
huge
low, Mr. Vivek.
experience.
Your voice is very low. Sound is low.
Okay, voice
वो
is
अभी
low.
उसे बोला नहीं ना अभी वो सेकंड
Hello.
ट्रेनिंग का तेरा जब
I
देगा
think
ना
there is
तब
some
तेरे को
issue.
देखेंगे भाई ये भी अभी कोई क्वांटिटी के साथ फाइनल हो गया
Can all you hear me?
बना है.
Akshay?
Yes, we can hear you.
Okay, yeah. Please proceed, Mr. Vivek.
हाँ खाली वही जो
Yeah.
माइनस क्या हुआ
So,
क्या नहीं हुआ
sir, it
है ना.
was a very
हाँ हाँ.
interesting and breathtaking information. And some of
काय
the
घेतलं
things,
ना ऑर्डर
even
करून
when I
घेतलं
was with Afcons for 10
नाही
years, I
हवा
could,
घेतली काय नाही ना बस खाली
it all
मेन
flashed
रिव्हर
back,
करतो
all the
बसला
old
तर
memories
ती
of
हाईट होत जाईल.
Giridhar sir, then NV Nayak sir, Ajit Penkar
बसला
sir. And
बसला
then
त्याला
when
करून
we were working, you
अरे
used
बस
to
खाली
tell
ऊपर जाके
about
बोले
this
बोल बस
project
नहीं है
quite some time.
उसका वॉल
Uh,
कम का
One question
ज्यादा
from
करेगा
my
फिर पत्थर
side
कम का लगा तो
is
ज्यादा हाइट होगा.
after launching of this bridge, how did you do the load testing of this long 125-meter span? So that would be very interesting to hear from you,
जाके
sir.
चेक करके बता तेरा पैरापेट का विड्थ कितना
Yeah,
है.
see, basically, 125-meter
अरे देखो ये
span
खाली
was
बोलता 15
load
हिसाब से
testing was
वॉल
not
मेन
done. It
रिव्हर
was
का
actually
दूसरा
checked
वॉल
on shore only when it was got assembled over there
जो भी है.
because it was
Okay.
on shore. So it's always better to do the load test at on shore instead of on the river. So it was tested on shore. But for the T girder and the full span box girder, we did the testing load test by putting the cantilage on the girders and observing the deflection for the given time and concluding the test.
Yeah, and this being a huge project, another curious thing which is question coming is how the safety was ensured because it I think this project went for something like 3.5 years old. I mean duration. So in
Correct.
3.5 years, how the safety was ensured that people should not get hurt or there are no near place missed incidences happening because there are barges, cranes, and maybe you people might have worked in even night time sometimes. So how the safety was ensured?
Yeah, see, basically, definitely those period were not the people were so much aware about the safety. In fact, what we could see is that at that point of time, because of the Konkan Railway, they used to strictly ensure that all people are wearing these helmets. Then, whenever they are doing work at height, they are having that ropes attached with their lifeline, waistline. So all sort of things. They only pressurized and ensure that the people are following the doing the work very safely. But it was not so easy at that point because still we had few of the accident was there. Okay, because of the current river in the river and the conditions were there. But still, I can say that started implementing right from then. It was a start, we can say, beginning. But still, we did work very safely, even though it was very challenging because all the hydraulic works involved, pre-stressing, pre-tensioning, doing piling in marine condition. Pneumatic caisson itself was a very, very challenging task. We had few of the incidences there when we did the bottom plug. I think we'll have one same webinar
Yeah,
on the
yeah.
pneumatic caisson itself.
Because
Okay, small
pneumatic
webinar. So
pressure.
और कौन गया.
it's quite with challenging work basically. So that we
Yeah.
can have
I think
in
Vadalkar
that
sir
time.
has one question. Sir, please ask your question.
Yes, sir. Yes, Hemant sir, you can ask question. His voice is not coming.
I'm not able to ask. Mr. Nihal, you can ask your question. You can unmute yourself and ask the question, or you can put it in the WhatsApp group itself. So
Yeah,
Mr. Nihal has asked a question. He is asking what type of concrete testing was conducted on site, that is slump, cube, cylinder, etc., to ensure the quality, and also what steps were taken during construction to reduce or eliminate the delamination or the cracking. So here Mr. Nihal has asked two questions. One is what type of tests were conducted, slump and cube, cylinder, etc., and second question is to avoid cracking, what action were taken,
yeah.
because this is
See here
almost
at
like
that.
30, 30,
Okay, see
35
here
years old.
basically. Here, basically, we had a very good setup for the quality control, a good lab. I can say in my 35 years of the span, such a beautiful lab I have never seen anywhere. Even though we had imported equipments and all. Here, basically, what happened? We, as per the contract, we were supposed to do the testing, cube testing, and the permeability test on the concrete for the pre-stress concreting. So all the pre-stressing concreting, we used to take the uh, do the permeability test as per DIN 1048. We had a good equipment from the Germany at that time. Afcons bought it at one of their Iraq projects. Same thing, same equipments we use. We used to do it can accommodate 6 samples at a time and do the permeability test. That was a West Form Plus test Sidner from the West Germany. At that time, it was a West Germany. So that equipment was from the West Germany, Form Plus test Sidner. So permeability test, cube testing machine. Again, we had that equipment. Luckily, from the same place, same make, Complex Test Sidner. And we had a chemical test lab. In fact, it was a very astonishing thing for the Konkan Railway complete staff because they said that this is a very important area where high marine environment is there, lot of chances for the corrosion. Already we had one accident over there, Mandovi railway bridge, which got collapsed just few years back. So a lot of emphasis were given for the concrete quality control. So we established a good lab. We had a chemical testing lab in a complete manner. We had a volumetric analysis to do the chloride testing. We had all the equipment for doing the sulfate test. We used to do the soundness test for the aggregate at site with the MgSO4 and Na2SO4. And then all sort of tests we used to do at site itself, all chloride tests, sulfate tests, complete testing for water. We used to do at site. In fact, it was very astonishing there. Water from one of the source we used to use for the drinking purpose, but we were not using for the
Oh,
concreting because the pH was less than 7. Our requirement was pH
oh,
should be less than 7, more than 7. Okay. And this particular source was having little lesser than 7. So it was not being allowed to use for the concreting. So much of
oh,
stringent surveillance was there and control was there from Konkan Railway. And in fact, they had their own system of training their own people, and really we also learned a lot from them because they were having their one of the consultant AP Remedios. He used to train their engineers for the
oh,
quality. So that time he was number one in India, AP Remedios. Okay, he was there abroad for many years, then he came to India and he was from Goa, so he quite used to visit very frequently our project, training Konkan Railway engineers, looking at the way work we are doing. In fact, one of the time, Mr. Professor M.S. Shetty, he had visited our project along with Mr. Samir Surlakar. Okay, and he had
okay.
seen my lab setup, means our lab setup. He was very astonished to see that. And the moment that time we were doing the T girder concreting. He saw the concrete and he was so impressed. And then he said to me, "My boy, I liked your work. Your concrete looks like butter." And he gave his own book, making autograph to me. This is a gift from me. Keep it from my side. I was very happy and I had a pat on my back. So it was a really great appreciation for me. Big concrete technologies appreciating my work at site. That too, really beginning of my career. We did lot of things there. Definitely, our concrete was number one. I still remember means the effort we had taken. Really, it worked well, and he paid a lot of value to that. Yes. And at site, if you
Great,
see
great.
at site, definitely now this is a part of the lab and all testing part. So definitely we used to do maximum test at site in presence of Konkan railway engineers. And only test we used to do outside was the petrography examination for the rock and the potential alkali reactivity. These are the two tests we used to do either at VZTI or one of the colleges, engineering colleges. Okay, or rest all tests we used to do at that point of time at site itself. Everything we had, all the setup. At site, if you see, when we used to do the concreting, definitely, as I told you, we used to give a lot of emphasis to see that there are no cold joints. So this is one part we used to observe. We used to check the initial setting time at site. So we'll take concrete, fresh concrete in a bucket. We'll put 25 needle and we'll see at what time it remains workable. So that when we put the
Okay.
subsequent layer, both the layers get intermixed with each other and there is no formation of cold joint. So that we used to follow
Oh,
very strictly. Okay, and whenever there is any bleeding, because that time we were not having such PC based admixtures, our water cement ratios used to be little higher. What we are doing, it is very lower water cement ratio right now. So that time there used to be a bleeding because sometime there will be less fines in the sand and we'll have some bleeding. But we will remove that bleed water. Will not allow the
oh,
subsequent layer to fall on that water. First, Kokandal will ensure all our accounts engineers that we are removing all the bleed water with the sponge and everything, okay, and then
oh,
putting fresh concrete on that if any bleeding happens. So, lot of precautions we used to take at site, observe and ensure. In fact, for the full span, this 53.5 box girder and T girder, our finish used to be like a mirror finish. So, lot
okay.
of and what
Yeah.
second thing, when we are doing the pneumatic caissons, anywhere we need to make the construction joint, we will use the surface retarder. We'll use the surface retarder
Okay.
on the surface, and just before initial setting time, like within 2 hours, we'll do the water jetting. Complete slurry will be washed out. You can see the fresh aggregate on top, which is excellent construction joint. So both the thing we used to follow very religiously: formation of the construction joints and prevention of the cold joints,
Oh, wow.
bleed water. So, what are concrete
That's
defects happen during the placing? So that we used to take care.
great, great. Because today's time we have got so many, phosphor chemicals and etc. are there, but in
Yeah,
35 years back, hardly something was there. So it's really interesting, like you mentioned, removing the water with sponge. So it must have been painstaking. So there are a
correct.
couple of appreciations coming up, and there are a couple of questions. Our ISSE President Hemant Vadalkar sir is saying, excellent presentation by Mr. Gaikwad. I could
Thank
get
you. Thank
opportunity
you, sir.
to work on Konkan Railway Station project from SPA and SD Limaye. So, sir is also has worked with Konkan Railway, so he has experience,
Yes,
and
yes.
probably he might have seen how stringent they are.
It's very
Then
good.
there
Very
is
good
one
culture was
question
there.
coming.
Yeah.
There is another question coming by Mr. Akash Mahajan. So he's asking, any extra special forces considered in design and what type of hurdles in design? So probably he's a designer, so wants to understand whether any additional forces were considered because of the barge lifting, and then there were, current forces were there. or the lifting position of the barge, Sahyadri barge was adjusted at the lifting position of the girder itself. So something, some light you can throw.
So basically, for the breach part, definitely the design was of the Konkan Railways, so it was not done by the AFCONs. But
Okay.
definitely that Sayadri Baj and all the schemes, those were formed for the erection and all. The from the AFCON side, designer like Kelm and all, they have considered the current of the velocity of the reverse flow in the channel, the scouring depth, wind velocity. So such kind of dynamic forces, those were there. We They have actually considered and ensure that it withstands with all the forces. Otherwise, for the structure, definitely it was done by the Konkan.
Okay, sir, and another thing from this question, it points is, all these things like forces, stresses, all these pre-stress concrete, steel structures, as you mentioned about riveting, people were using riveting. So all these things are taught in colleges nowadays, but then students feel that this is not of any relevance in practical life. But it's not like that. Your presentation is an example of that, that whatever is taught in colleges is really useful for them. They should not forget these things, right?
Correct.
Yeah. So, any more questions? Please unmute yourself, or you can put it in the chat box, or you can give it in our ISSE webinar WhatsApp group. Yeah, Anil Khandelwal sir is saying excellent concrete quality work and limited resources in those old years. So, sir, congratulations to you again, because I
Thank you.
was fortunate enough that during AFCON's tenure, I could, almost like weekly or daily, I could meet you and understand those experiences. But probably boys are listening to you first time, so they are overwhelmed to yeah, Khandelwal sir is saying congratulations. So, Khandelwal sir is from our Madhya Pradesh region, Indore region, and he has recently set up a ISSE new chapter there, and he's quite enthusiastic and very experienced senior professional, and keeps doing so many activities in the local region. So probably maybe you we can set up your one more session on maybe this caisson sinking in for an indoor chapter.
Sure, sure, sure.
That would
I will
be.
actually, I have decided I have a lot of knowledge to share with the students. So, in coming days, definitely I will make my own plan, schedule, how many topics that I can cover. I will share with you people. And then you can take a call how we can go ahead about it. Because I would be much more interested to share my knowledge and experience with the student forum in a forum like this, basically, so that they learn from this, they can pick it up something they can implement and they can really uh, make a use of it.
Yeah, yeah, yes, sir. And today I would like to say that almost like 40 plus students have attended right from VIT Vellore, then Ram Meghe College of Engineering, and some people are, I can see there from IITs also. So, and few of them are having Ganpati at their home. So, I would like to tell that Deepak Gaikwad sir himself is having Ganpati. You can see in his screen on the left side. But still, he managed to find a time to deliver such an interesting presentation to us. Khandelwal sir is asking, we would like to you to deliver a lecture at upcoming inauguration of student chapter at PIEMR Indore. So probably you got an invitation, sir, for inauguration of the Indore chapter. Maybe it's nearby to you, so probably
Yeah, it's near from Baroda.
you
Actually,
can
I'm
travel.
stationed at Baroda. It is near, correct?
Yeah, yeah. So probably you can start in the morning, then or afternoon, go to there. So that we can discuss how will be the modus operandi and
Sure,
all, sir.
sure, 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 sure.
Yeah. So are there any more questions, or should we wrap up the session? Any more questions? Ekalavya is asking, I have a request. Mr. Ekalavya, what is your request? Please tell. If you have a request, you please keep it in the WhatsApp chat. If it comes later on, also I will pass it on to Deepak sir, and I'll ensure that your question is answered, like we did last time. Also, some of the questions came late evening, so still Shekhar Vaishampan sir answered them. So, sir, now I would just like to give a small wrap up of this session. Today's what you covered is initially you started with the scope of the project, that is Konkan Railway, 740-kilometer long stretch. Then where MJBs are 179 MJBs are there in this project. As a bridge designer, I can imagine the mammoth task to design
Correct.
179 bridges. Then there were MNB like 1670 MNBs there were there. So that is another challenging thing. Then you started about Mandovi 1 and 2 bridge with its Google Map, and then how there was a background of collapse of Panji old bridge because of the corrosion of PSC strands. Then how the girder of 53-meter weight was 800 metric ton. So I can just imagine how to lift 800 metric ton in a river and how to launch it. It's a huge task. Just to tell to students, like in Indian context, one elephant would weight 5 ton. So this is something like 5 tons. So this is something a weight of 40 elephants was lifted in using a Sahyadri barge. Then, sir, you emphasized on the casting yard reinforcement, and then how the cold joint was avoided, how the water cement ratio was taken care of, then how the Sahyadri badge, which was 40-meter long by 14-meter wide, having two legs, was used in lifting up. It used to enter inside the casting yard and pick the girder. How the tidal situation, currents, wind speed was adjusted during the working conditions. Opposed to this 53-meter girder, you discussed about the T girders, 22.8-meter casting the T girder. What was the unique thing which we observed is a steam curing, because generally steam curing is not very commonly taught in colleges. So steam curing is another interesting thing. In this same thing, you also spoke about CSET launchings. In 2020, 2002, when I was working in the HCC, Hindustan, I used to hear about CSET launching, but I had never seen, which I could see in your slides only. So that was very interesting, sir. Then you spoke about presence of and visit of E. Sridharan sir. We call him as a metro man. We identify him as a metro man in India, and Padma Shri Award winner, and how he appreciated the work done by your team. Then you also showed the completion certificate by Konkan Railway, which itself is a difficult task to get such a nice completion certificate. And you mentioned about NV Nayak sir, Kashal Sarkar, Giridhar sir, Ajit Penkar sir was, it was like old memories for me also. And then you spoke about, the testing concrete test lab for the chemical analysis using DIN 1048. That was another important thing because hardly any construction site has a chemical testing lab. Generally, they have cube testing and all those things, but chemical testing lab was something like unique. And then lastly, you mentioned about the supervision by involvement of Sir AP Remedios, late AP Remedios, then Dr. M.S. Shetty, Samir Suralkar sir. So these are all doyen names in the industry. So which you could face them and convince them about the quality of concrete, the launching works. So that's really a commendable job. So I think, yeah, there are two more questions which have come. I'll just quickly take them, sir. Sir, can you get the session in Dr. Yeah, Durgapur? So, okay, we'll discuss that, Mr. Ekalavya. We can arrange a session at Durgapur College. I'll discuss with Gaikwad sir and check his availability, because he is working in one of the India's highly busy site is, so I have to check his availability as well. Mr. Anubhav Sharma is saying, good morning, sir. Unfortunately, today, yeah, don't worry. I'll ask Gaikwad sir to share some of his slides, important points. And Vadalkar sir is saying, request Deepak Gaikwad if he can make a small write-up paragraph about the project execution. We would like to publish in ISSE journal. Yeah, that's a offer to you from our president of ISSE, sir. So please. Give a small write up to us so that we can publish it in the coming journal.
Sure.
So, yeah, I would now let us thank Deepak Gaikwad sir on behalf of ISSC entire managing committee and student chapter group. In spite of having a busy schedule and Ganpati
हॅलो.
festival at his own house, he
हां बोला.
promised me and accepted this invitation and delivered this
नाही
session,
होते.
excellent
नाही येते
session.
येते.
So I announce a formal closure of this session. Thank you, sir. Thank you very
नाही
much.
काही
And
नाही
thanks to
सगळ्यांना.
all the participants. Have a good
Thank
day.
you, thank you. Thank you, Mr. Vivek
हां.
ji, and all providing me such an opportunity to share
नाही
my knowledge,
चालते.
experience. Thank you all. Thank you.
नाही
Okay.
सुरुवातीला आम्ही
Have
चेक
a good
केलं
day.
सर
Bye.
सगळ्यांचा आवाज येत होता बरोबर.